Okay, now let me explain again one more problems related to this change of order of integration. If, in this case, we have to evaluate integrals 1 to 2, x to 1 by x square by y square to x dy by changing the order of integration. We cannot evaluate it like this by changing the order of integration, because according to this limit given in the question, x, the limit of x are this one, x is equal to 1 to x is equal to 2, and y it is equal to x to y is equal to 1 by x. So by changing the order of integration, I need to find out a new limit for y. Now it will be in terms of constant, and for x it will be in terms of y. So to obtain this one, we have to draw the graph of this one. X is equal to 1 to x is equal to 2, y is equal to x to y is equal to 1 by x. So here I have mentioned this one, the limits of integration for x is from x is equal to 1 to x is equal to 2, and for y it is from y is equal to x to 1 by x according to the question. So using this one, or drawing the graph of these limits of integration for x and y, we can find out the new limits of integration for y in terms of constant and for x in terms of y. So what is, you can draw in the xy plane. Now for x is equal to 1, x is equal to 1, it will be this line. This is x is equal to 1. X is equal to 2, it will be this one. And then y is equal to x. Y is equal to x, you can see from the table, it represents a straight line which passes through the origin. When x is equal to 0, y is equal to 0. When x is equal to 1, y is 1. When x is 2, y is equal to 2. So you draw the graph of this one, it will be like this. So this one is y is equal to x. Now next, you draw the graph of this one. Y is equal to 1 by x. Just take some points only and for x, and then you can plot those points. So for when x is equal to 0, okay, here there is mistake, because when x is equal to 0, y is equal to infinity. So here let us take x is equal to 1. When x is equal to 1, y is equal to 1. That means this point here. When x is equal to 2, y is equal to half. It will be somewhere here. When x is equal to half, y is equal to 2. So in this case, the graph will look like this. It will come closer and closer to both the axis, that is the y axis and the x axis, but it will never touch the x and y axis. So now you see that this will be the region of integration. This shaded region here. So from this shaded region here, we have now to find out the new limits of integration for x and y. To obtain this one, what we need to do is we can split this region into two parts. Now here this x is equal to 1 is a point of intersection of the graph y is equal to 1 by x and y is equal to x. So you can draw a line here which passes through x is equal to 1. This is x is equal to 1. Now this is region A and this is region B. Now in region A, let us find out the new limit of integration for x or for y in terms of constant. And here you see that the point of intersection of this y is equal to x and the line x is equal to 2 is at this point, which is x is equal to. You can draw again this line which is y, sorry, I made mistake here. This is y is equal to 1, this is y is equal to 2. So now here you see that in region B, this B, the point of intersection of this one is x is equal to half. Sorry, not x is equal. When x is equal to 2, then what is this? Y is equal to 1 by x, it is equal to half. So again, you can draw a line which passes through this one. So this is y is equal to half. So now you see that this region B is bounded below by y is equal to half to y is equal to 1. And for the x, to find out the limit of x now, it is, you see on the left, it is bounded by this curve y is equal to 1 by x, which can be expressed as x is equal to 1 by y. And to the right, it is bounded by x is equal to 2. So here, you see that in region B, the limit of integration, limits of integration for x will be, always remember that for x it will be from left to right. On the left, it is bounded by this curve y is equal to 1 by x, which can be expressed as x is equal to 1 by y. So the it will be x is equal to 1 by y. To Now to the right side it is bounded by the line x is equal to 2, so 2x is equal to 2. So this will be the limit of integration for x in terms of y and in terms of constant. One is in terms of y, one is in terms of constant for the region B. And for y it will be, for y it is bounded below by y is equal to half. So y is equal to half to y is equal to 1. So the new limit of integration now for the region B will be this one. And for region A, let us find out for region A, what is the limit of integration? For y it is from, you can see from the figure, it is bounded below by y is equal to 1. So y is equal to 1 to y is equal to 2. And for x, it will be on the left side, it is bounded by, you can see from this figure, it is bounded by the line y is equal to x. So y is equal to x means that x has to be expressed in terms of y. So for y, it will be in the region A. For x, it will be from x is equal to y on the left, and to the right, it is again bounded by the same line x is equal to 2. So x is equal to 2. So therefore, the new limit of integration now, for that double integral 1 to 2 x to 1 by x, x square by y square dx dy. Now this can be written as, since we have split it into two subregions, so the first one will be integral x will be y is equal to half to y is equal to 1, then integral for this one with respect to x first. Now it will be from 1 by y to 2, then x square by y square dx dy, plus now double integral for the region A. For the region A, we have this limit of integration. For y, it is from 1 to 2, and then for x, it is from y to 2, x square by y square dx dy. So now here you can find out what will be the limit now. What will be the value? It will be integral 1 to 2, also 1 by 2 to 1, then you can take that what dy by y square outside that first integral. So it will be 1 by y to 2 x square dx. So you can integrate first this one with respect to x, substitute the limit of integration, then you'll get in terms of constant and in terms of y. So everything will be in terms of y, and then after that integrate with respect to y and substitute the limit of integration. And for the second part also, this is 1 to 2, then integral. Now again dy by y square can be taken outside that limit of that first integral, because this will act as a constant when you integrate with respect to x. So it will be integral y to 2 x square dx. So integrate this one now with respect to x, substitute the limit of integration, then you'll see that everything will be in terms of y and in terms of constant, and which can be easily integrated, and then you substitute the limit of integration for y. So this is the way of finding the new limits of integration when we have to change the order of integration. In some, you can see that in the original one, it is only a single double integral, but by changing the order of integration, we'll have two double integral. By splitting the middle term, by splitting that region of integration given in the original one, we will be able to find out the new limits of integration for x and the new limits of integration for y. I hope it will be clear now. You just go through it. In case if it is not clear, you please let me know.